This is video number 5 for Integrated 2, focusing on polygons. This is going to be the longer video of them, just has more work that needs to be done. This is the area of a regular polygon. I have 3 examples for you here because each one is giving you a different bit of information. So what we would do is go through and identify where the center of this is coming from, which it is identified for us, and then create triangles. So I'm going to go ahead and create all of my congruent triangles here. So by creating or identifying the radii, or each radius, connecting to the corners, you'll notice that we end up having 5 triangles. These 5 purple triangles are all congruent to each other. I'm only going to focus on one of them because if I can find the area of one of the triangles, then I can just times that by however many triangles I had. So in this case, I'm going to have 5 triangles, which means after I find the area of one of them, and I'm going to focus on the one on the bottom, after I find the area of one of them, I can just go ahead and times it by 5 itself. So get my total. All right, taking a look at this, I have a right triangle. You have to decide which angle that you want to find. You can find the angle up in the middle. So if I go back up to my picture where my purple triangles are, you can find this angle up in the middle that I just marked in purple. Knowing that this is a regular pentagon, I know that every single one of those angles is congruent to each other. I also know that the apothem that I just drew in, the red line segment, is going to bisect that angle, cut it in half. So I think that's what I'm going to do. I'm going to find that angle in the middle. So to go ahead and find that, I know that all of those angles in the middle together add up to 360. So I'm going to take 360 and I'm going to divide it evenly so it goes into each one of the pentagons. So if I do each one of the triangles. If I do 360 divided by 5, that's going to give me 72. But because the apothem bisects that, we need to cut it in half. So that's actually going to be 36 degrees. So back to my picture. Go ahead and identify this in black so we can see it kind of standing out a little bit in the picture. That is this angle that is going to be 36 degrees. Okay, now from here, in order to find the area of this purple triangle, I am going to need to know the base of the triangle itself. And the base is going to be all the way across, because we are trying to find the area of the purple triangle, not just the one that I cut in half. So I'm actually going to call this B. It's this little part, knowing that the apothem bisected the base, or the side length. All right, if we take a look at this triangle, I now have enough information to be able to do some trig. So let's do that. So let's find A first. Using the 36-degree angle that I found, the 4 side length on the radius, and the A that I've identified as the apothem, I can go through and say that this is cosine. So I know cosine of my angle, which is 36 degrees, is equal to adjacent A over hypotenuse 4. Go ahead and solve for this. This is going to give me 4 times cosine of 36. Okay, I'm going to use that as my apothem length. Doesn't look like much right now, but I don't want to use a rounded answer to get another answer. So I'm going to be super careful here. Let's see if we can find B. B looks like it's going to be sine. So sine of the angle is going to be opposite over hypotenuse. We'll do the same thing here. It looks like B is going to be equal to 4 times sine of 36. All right. Now to find the area of my purple triangle here, and this is going to be the area of just one of the triangles, this is going to be the base times the height divided by 2. Well, if we take a look at this, we know that the base is technically 2 B's. This is B plus B back in our picture, which we know is 2B. So it's going to be 2B times the height, which is the apothem, and that's going to be divided by 2. Notice that the 2's here on top and on bottom are going to cancel. So what this gives me is actually B times A. So that's going to be the area of my triangle. I'm still not typing this in my calculator yet because I'm going to use those answers to find something else. All right, now we can actually find the area of the entire shape originally, and this is a pentagon. So we know we're going to have 5 of these. So the area of the polygon is actually going to be 5 times the area of the triangle that we just found. So at this point, I know this is going to be 5 times, okay, well, the area of the triangle was B and then A. Now I'm actually going to start grabbing my calculator. So I'll do 5 times, well, B was identified as 4 times sine of 36 times the length of A, which is 4. Type that into our calculator and we'll find the area of the polygon. And our approximation is going to be 38.0422 units squared. So that's the area of the polygon. Okay, moving on to the next one. Calculate the area of the regular polygon as well. Notice this is a hexagon. I chose to do a hexagon because we know that there's going to be 30, 60, 90 triangles that show up in this one as we discussed in class. So with that said, you are expected to use the special right triangles, not necessarily trig in this one. So, and I also gave you different information that has been identified within the picture. So if I go through and I identify the radius, if you take a look at this, I am going to have, this is a hexagon, which has 6 sides, which means I'm going to have 6 purple triangles. Now I'm just going to focus on the one that was given to me. So find the angle that you want to find. The process is going to be the same as what we did before. So I am going to find the angle up at the very top there, which I know is going to be 360 divided by 6. So that's going to give me 60 degrees. However, as we know, the apothem bisects that, and that gives us 30 degrees. So using the triangle where I have my information, that is going to be 30 degrees, which means that this is going to be 60 degrees in that corner, and if it's 90 degrees on one side, it's 90 degrees on the other side. At this point, I have to identify, I've got my apothem, that's good, I need that information. I do not need the radius, the purple length, but I do need the base itself. So let's go ahead and color code that length. So I need to find this length in orange that I just highlighted. All right, so using what I know about special right triangles, I know that a root 3 is going to be equal to 12. So let's go ahead and simplify that so we can find the shortest side, that orange length. That's going to give me 12 divided by root 3, and I'm going to rationalize this. So root 3, looks like A is going to be 12 root 3 over 3, which we know can be simplified. So it looks like that is going to be 4 root 3, and that's just my orange location here. So this is 4 root 3. Okay, I think I can now find the area of the purple triangle. The area of the purple triangle is going to be the base of it, which in this case is going to be the base of the triangle is where the perpendicular business happens. So we're going to have 2 of the 4 root 3s. So that's the base, times the height, which is the apothem. That is where the perpendicular happens. So the apothem here is going to be 12 divided by 2. Notice that the 2's cancel again. This will always happen, which is really nice. So this is going to give me 4 root 3 times 12. Well, that is 48 root 3. So that's the area of my triangle, just one of them. But then I have to go through and find the area of the entire shape that I started with. So the area of and it is a hexagon. Well, there are 6 of them, so we're going to have 6 times the area of the triangle. So if I do 6 times, the area of the triangle was 48 root 3. If I multiply the 6 and the 48, that's going to give me 288. And then just carry the root 3 with you. Don't forget units squared. So that's the area of our hexagon. So same idea. We're just carrying along with this. All right, one last example on this. Calculate the area of a regular octagon with side length of 7 centimeters. I'm only going to look at the triangle because I know that there are going to be 8 of these that are congruent. And I know it's 8 because this is an octagon. So from here, I'm going to head and draw in the apothem that I'm going to be using, knowing that that is where the 90 degrees is going to occur. So perpendicular is going to be the side length with the radius. The side length with the apothem. So that's where my perpendicular is going to happen. I am also going to find the angle up at the very top, and I'm going to fill in the information that I have. So the side length is 7. So that means this whole length here is 7 units all the way across, which means in the little triangle that I'm using, this is going to be 3.5 since it is half of the length that was given to me. All right, I'm going to find the angle that I just identified in green up at the top. So I know that's going to come from the center. That's 360. This is an octagon, so it's going to be split into 8 pieces. Take the 360 divided by 8. That's going to give me 45 degrees. But remember, that angle still needs to be cut in half. So if I cut that in half, that's going to give me 22.5. All right, so the green angle here is 22.5 degrees. All right, I already have the base, which is good. It looks like all I'm looking for is the apothem. So let's go ahead and do this. 22.5 is not special for a special right triangle, so I'm going to go ahead and just do some trig here. So it is going to be tangent of the angle 22.5 is equal to opposite 3.5 over adjacent A. If I solve this, this is going to be 3.5 divided by tangent of 22.5. Now, I'm not going to type this in my calculator just yet. I have to use this for something else. Okay, let's find the area of the purple triangle now. So to find the area of the triangle, I know that it's going to be the base, well, the entire length of it was 7, times the height. Well, the height is the apothem. So I know my A goes right there, and then I am going to divide by 2, which, I know the 7 and the 2 don't simplify exactly, but it really does turn into the 3.5 we had a second ago. So it's going to be 3.5A. All right, so that's the area of one triangle. This is an octagon, so that means that there are going to be 8 of these. So the area of the octagon is going to be 8 times the area of the triangle. So that's going to give me 8 times. I'm going to use parentheses here only because there's a decimal on the 3.5. Then I'm going to plug in what I know for A. So this is going to be 8 times 3.5 times, okay, let's plug in the information for A, which is going to be 3.5 divided by tangent of 22.5. Last thing I need to do is plug this into my calculator and get an approximation. And our approximation here is going to be 236.5929 units squared. So that's the area of our octagon.